All right, let's do a little lesson on equal jumps on a number line for multiplication. So let's do, this pen drives me crazy. 4 times, we did 5 on our homework, so let's do 4 times 6. Okay, so we want to show equal jumps on the number line, and you have a blank number line, so how do we do that? Well, we know that we want to go ahead and start at 0. And what do we have? We have talked about multiplication as being two things. 1, repeated addition, and 2, sets of. So if we have 4 sets of, or groups of 6, how could we do this? Well, we can count up to 6, and we should do that 4 times. So we want to add 6 4 different times. I'm telling you, this pen, need a new mouse. Okay, so we'll jump to 6, and now we need to add another 6. So we need to add 6 4 different times. So here's 1. We need to add 6 again. Where is that going to put us? 6 plus 6 equals, see if you can get it, 12. And there's our second jump on the number line. And I'm going to label everything because I don't want to forget. So there's our second jump, 2. So now out of the 4 we have 2 jumps done. I need to add 6 again. I'm going to write it. Okay, so 12 plus 6 is, can you get it? 18. Okay, so let's do our third jump. Now we've got 6 done 3 times. Now eventually you'll be really fast at this, but we have to actually understand what we're doing and not just be able to do it, but to actually understand what the numbers are doing. Because if you remember, I've always talked about, I want you to picture something. So you can picture a number line, or you could picture some groups of things. But however you do it, we need to actually be picturing numbers. And then that way when we do memorize facts, we understand what it is that we're memorizing. So we wanted to add another, excuse me, another 6. And now we have 18 plus 6 is 24. And if you're not using a mouse and you're just drawing this on your paper, hopefully you'll be able to do this a little bit faster. Oh my goodness gracious. Okay. And there's your 4. Okay, so now I have jumped 4 times. 1, 2, 3, 4. So that's my 4 right there. So I have the 4 done. And I added 6 plus 6 plus 6 plus 6. So I did that part. And what's my answer? 24. So let's do that with something a little more simple, and then we'll do one that's a little more difficult. So let's do 5 times, let's say 3. You can do it 2 ways. You can do 5 groups of 3, or if you can show me what I told you, that you can switch them around, you could do 3 groups of 5. But let's go ahead and do it the way that it's set up, and we'll do 5 groups of 3. So we have 0, and we have 3, 6. Remember, you can always draw all your little lines in between, like 6, 7, 8, 9. That's a big old 9. 10, 11, 12, 13, 14. We'll do a big hatch mark for 15. Okay, I'm going to go a little bit farther. 16, 17, 18, just to show you how you can work this. Okay, so we added 3 every time, and remember to look at the spaces, not the hatch marks, because this looks like there's only 2 hatch marks in between 6 and 9. But remember, we count the spaces. 6, this jump is up to the 7 hatch mark, 8, 9. Okay, so we count the spaces to get the value. So let's see if we can do 5 jumps and see what that takes us to. 1, 2, 3, 4, 5. Okay, so we did 5 equal jumps of 3 each time, and that got us to our answer of 15. Now, one of the things I noticed on some homework sheets that I got back is that we weren't starting at 0. So make sure that you start at 0 every time you do equal jumps on a number line. Always start at 0. Now, if we were doing a different kind of problem, and it wasn't equal jumps on a number line for multiplication, like let's say you had to find, you had to find a big number like 1,280, and you had to find that in a number line. You're actually just finding it farther down the line. So like here's 18 on this number line. You could make that number line be huge, but to get all the way up to 1,280 by 3s, that would take us way too long. So instead, we're just going to look at a snapshot of the number line, and we might have, we might count by hundreds. So 1,000 here. See if I can make it all my zeros without making any crazy lines. Okay, 1,000, then we might do 1,100, 1,200, 1,300, 1,400, and 1,500. And we could just do a snapshot of a number line without having to do the whole thing. So 100, 200, 300, 400, 500. Couldn't remember what I did. 500. Okay, so that would be 1,280 if we were trying to find it. There's 1,100, 1,200, but we don't want to get all the way to 300. So to find that on the number line, it would be right about here. Okay, but this is just a snapshot of a number line further down. So we don't need 0 on there because we're just taking a small section of the number line. But when you're doing equal jumps on a number line, start at 0. Okay, so let's do one that's a little bit harder, and we'll count by 10s. No, I don't want pink. Okay. So let's do 10 times, let's do 4. 10 times 4. But we're going to switch it around like I said, and instead we're going to do 4 groups of 10 because either way we can get the same answer. So as long as you can tell me what you did. So now I have 4 groups of 10, and you know what? That's going to be so much faster than doing 10 groups of 4. So 0, and then we're going to count by 10s because y'all are so good at skip counting. So 10, 20, 30, 40. I'm going to label 40 because I already know from my skip counting that 10, 20, 30, 40 is 4 groups of 10. But let me double check and show that I know what I'm doing. I'm going to start at 0, 10, 20, 30, 40. So, do I have the 4 done? Yes, because I have 4 jumps. 1, 2, 3, 4. And do I have my 10s? Yes, because I added 10 every time. 10 plus 10 is 20, plus 10 is 30, plus 10 is 40. So I have 4 groups of 10. And I know that because of the commutative property, which means that I can just switch them in multiplication. Please note that you cannot do that with division, and you cannot switch it with subtraction and get the same answer. But you can in addition. 2 and multiplication. 2 plus 4 is 6, and 4 plus 2 is also 6. 10 times 4 is 40. 4 times 10 is 40. Either way. But when you get to division, that won't work, and you guys have learned that in subtraction, it won't work either.